All right, the last video we looked at was the Maclaurin series, and that's a special type of Taylor series that is centered at 0. Today we're going to look at Taylor series that are centered at any other point. So if it's centered at another point, your Taylor series, it's not a Maclaurin, it's a Taylor series, and we would have some other value there for A. So let's look at an example. This is one we looked at last time, the function e to the x, except it was the Maclaurin one at 0. Now it's centered at 2. So we're going to do the same thing we did last time. We know that for a Taylor series here, or any Taylor series we're doing, we're looking at the summation here of f of n. Before it was at any point, but now it's going to be at a here. So in this case, a is going to be 2. So we got a equals 2 here. All over n factorial. And now here, instead of x to the n, it's going to be x minus whatever our a value is to the n. And so this time, again, because we're doing it at 2, this will be a 2 here. Okay, so let's find those derivatives to start with. So for our different values of n here, let's go 0, 1, 2. We'll go, let's go to 3 here. And then we got our f of n at x. And then we'll also figure out here what's our f of n then at our specific value of 2. All right, so the original function, if n is 0, that's just going to be our original function up there, e to the x. And that at 2 would end up being e squared. First derivative of this, if we did first derivative of this function, we'd get e to the x. If we did second derivative, we get e to the x. This is a nice one for looking at first because every derivative, doesn't matter what derivative we're looking at, is going to remain e to the x. So first derivative is e to the x, evaluated at 2 is going to be e squared. Second derivative is e to the x, evaluated at e squared, and that's just going to continue here on down here. All right, so if we start filling this in now, let's see what this Taylor series looks like. So our function then evaluated at 2, since they're all the same here, this would end up being e squared, since they're all the same, over n factorial. And this is always going to be x minus 2 to the n. So let's write out the first couple terms here. So that first term, and I suppose I should put this in here. This will be from n equals 0 to. So if we start with 0, we're going to have e squared over 0 factorial. And then if we put 0 in here, it'd be x minus 2 to the 0. So that would evaluate 0 factorial is 1. Anything to the 0 power is also 1, so that would just end up being e squared. All right, let's find the next term. So now it would be e squared over 1 factorial, and this would be x minus 2 to the first power. Well, 1 factorial is 1, so we'd end up getting e squared times x minus 2. All right, let's figure out the next term. So now we get e squared over 2 factorial, x minus 2 now squared. So this would simplify to e squared over 4, or sorry, 2 factorial would be 2. 2 times 1 is 2. 2, and then this would be x minus 2 squared. If we want to go, let's go one last one here. If we did the third one, now it's going to be e squared over 3 factorial. 3 factorial would end up being 6. 3 times 2 times 1 is 6. And then this would be x minus 2 to the third. And then our series would continue there. To get a visual of this, let's look at that Desmos app we looked at last time. The link should be available for you again. So if we pull that open, you are going to get an application here that looks like this. Let's change this to the function we just looked at. So e to the x. Right now, it's the Maclaurin one centered at 0 here because our b is 0, and we went through this last time, seeing how as we increase these, it becomes a closer and closer approximation at 0. Let's change this to the value we're looking at now. So now we're centering it at 2. So you can see now we're looking at where x equals 2. If we follow it up, that's where we're trying to approximate the graph by. So as we increase the number of terms, there's the first degree one would be like a tangent line. Here's our second degree approximation. You can see around 2 here, very good approximation. Here's the third degree one. Now we're starting to get even closer. If I zoom out, you can see, look at it, the red and blue line are almost identical. Not so much when we start getting near about a half, but everywhere else looks pretty good. There's the fourth degree, fifth degree, and you can see it's starting to approximate it even more. Now even at 0, it looks like it's a pretty good approximation. Now we're starting to approximate even in the, for some negative values there. So, but around 2, it's very, 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 very similar.